In this video, I'm going to find the divergence and curl of the vector field f of xyz is equal to exponent of 2x cosine yi plus exponent of 2x sine yj plus 5x exponent of 2zk. So we are given that vector field. I'll go on and start by finding its divergence. If we are given a vector field f, by definition, the divergence is grad dot f, the dot product of grad and the given vector field. In this case, we are given a vector field with three variables there. So our grad is the one with three components. This one, partial derivative with respect to xi, partial derivative with respect to yj, plus partial derivative with respect to zk. So I'll write my grad there, and then take the dot product with the given vector. And if you still recall, for the dot product, we'll be multiplying the corresponding elements, so it will be partial derivative with respect to x of the exponent of 2x cosine y. So I will write that partial derivative there, and then go on to the next part, looking at components with the j. So we'll have partial derivative with respect to y of exponent of 2x sine y. So I write that partial derivative. And then for the last part, we are looking at the k there. We look at the partial derivative with respect to z of 5 exponent of 2z. So I write then that partial derivative. And the next step is now to evaluate those partial derivatives. We are looking at this part here and differentiate with respect to x, treating y as if it's a constant. The result that we get there is 2 exponent of 2x cosine y. I move on to the next part, this partial derivative with respect to y. We are differentiating with respect to y, treating x as if it's a constant, and the result that we get there is exponent of 2x cosine y. I move on to the next part, and this one here, we are differentiating with respect to z, and the result that we get there is 10 exponent of 2z. So what we are having there, if we look at this part here, we have some common terms there. 2 exponent of 2x cosine y plus exponent of 2x cosine y, it will simplify to 3 exponent of 2x cosine y. So our divergence there will be 3 exponent of 2x cosine y plus 10 exponent of 2z. So what we are having there is the divergence of the given vector field is 3 exponent of 2x cosine y plus 10 exponent of 2z. I now move on to the next part of obtaining the curl of the vector field f. By definition, if you are given a vector field f, its curl is given by grad cross f. So we have our grad, the one that I talked about before, this one, the three-dimensional one. So for the cross product there, we will take the determinant of the matrix that is first row I, j, k. The second row has the partial derivatives. The third row has the elements of the given f there. The exponent of 2x cosine y, exponent of 2x sine y, then the 5 exponent of 2z. So I will now go on and evaluate that determinant. And to evaluate the determinant there, I will use the first row. So by using the first row, I will close the row and the column containing the first element, the I there. Then we take the determinant of the uncovered elements. So for that determinant there, that's a determinant of a 2 by 2. So we'll be taking the partial derivative with respect to y of 5 exponent of 2z, then minus the partial derivative with respect to z of exponent of 2x sine y. So that will be the one which will give us for the ith component there. So I'll just write it down, the partial derivative with respect to y of 5 exponent of 2z minus the partial derivative with respect to z of exponent of 2x sine y I. I now move on to the second element there in the first row. So I'll close the row and the column containing that second element, the j, then take the determinant of the uncovered elements. So we'll be having the partial derivative with respect to x of 5 exponent of 2z, then the partial derivative with respect to z of exponent of 2x cosine y. We'll be subtracting that one. So the j there, when we are looking at the sign factor array, it's sitting on a negative. So it will be minus the partial derivative with respect to x of 5 exponent of 2z minus the partial derivative with respect to z of exponent of 2x cosine y j. So that's for the I there. I now move on to the element k. So I'll close the row and the column containing the k, and then take the determinant of the uncovered elements. And when you are looking at the sign factor array, the k there is sitting on a positive. So it will be just be plus the determinant of the uncovered elements there. So for that determinant, we'll be looking at the partial derivative with respect to x of exponent of 2x sine y, and then minus the partial derivative with respect to y of exponent of 2x cosine y. So we would have there plus the partial derivative with respect to x of exponent of 2x sine y minus the partial derivative with respect to y of exponent of 2x cosine y k. The next step now is to evaluate those partial derivatives there. The partial derivative of 5 exponent of 2z with respect to y, it gives us a 0. The partial derivative of exponent of 2x sine y with respect to z, it gives us a 0. So the result that we have there is just a 0i. So I go on to the next part there where we have the j, this partial derivative. The partial derivative of 5 exponent of 2z with respect to x, it gives us a 0. And the partial derivative of exponent of 2x cosine y with respect to z, it gives us a 0. So we would have a minus 0j there. I go on to the next part of this one here. We are now evaluating those partial derivatives. And the partial derivative of exponent of 2x sine y with respect to x, that one, it gives us a 2 exponent of 2x sine y. Then for the other part there, it will give us minus exponent of 2x sine y. And it will then cancel out with this minus sign that we have there, so that our result becomes 2 exponent of 2x sine y plus exponent of 2x sine y k. So what we are having there on this part here, 2 exponent of 2x sine y plus exponent of 2x sine y there, we can simplify that to 3 exponent of 2x sine y. So our expression becomes 0i minus 0j plus 3 exponent of 2x sine y k. So we have our divergence there is 3 exponent of 2x cosine y plus exponent of 2z. Our curl is 0i minus 0j plus 3 exponent of 2x sine y k. So that's the divergence and curl there.